In this next section, we're going to focus on finding the equations of lines, which is probably one of the most important parts of algebra that we need to review. First thing, there are three forms of a line. There's standard form, which is ax plus by equals c. The perk of standard form is it can give you the x and y intercepts easily. The next form is slope-intercept, which is y equals mx plus b. Obviously this form I don't think I need to review much. It's just a slope and intercept are given. The last form, which is the form which you guys use the least, is point-slope form. If you look at the name, slope-intercept, it gives you the slope, it gives you the intercept. Point-slope gives an equation of a line given the point and the slope. And it looks like this. It's y minus y1 equals m times x minus x1. It makes a whole lot of sense. There's a slope, m, and the point, x1 comma y1. If you look at the actual form, it should be very obvious to you why this form works. We know that slope equals y2 minus y1 over x2 minus x1. If we multiply this to the other side, we get y2 minus y1 equals m times x2 minus x1, which is where point slope comes from. Now, one more quick review before we actually do a problem, and that is some key terms from geometry. So in a triangle, we have a perpendicular bisector. This isn't even in a triangle, but a perpendicular bisector in general would be a segment that bisects another segment at a right angle. In a triangle, this segment would come from, obviously, one of the vertices. Number two, the median line. The median line starts at a vertice and it goes through the midpoint of a segment. So for instance, if I draw this triangle over here, if I start from this vertice, the midpoint's about there. You can see that this median line is not a perpendicular bisector. 3, the altitude. The altitude is the line that begins at the vertice and is perpendicular to the opposite side of a triangle. In other words, if the median and the altitude line up, let me draw the altitude in this triangle right here. Oops. If those line up, here's the altitude, here's the median, then that triangle would have to be isosceles or equilateral. That's basically what we're saying here. So if the perpendicular bisector is formed by the median and altitude lines, that means it must be an isosceles or equilateral triangle. So with that, let's do one problem. And the problem is going to use the vertices. I'm going to flip this page over. Let's let A be 8, 5, B be 0, 1, and C be 9, -2. I am going to draw a quick graph, just so I have a quick sketch. So 8, 5 is A, B is 0, 1, and 9, -2. There it is. So first question, let's find the length of BC. So first question, let's find the length of BC, and let's find its equation. So to find the length of BC, let's review the distance formula. So from B to C, we have the square root of the x's, the difference of the x's, so 0 minus 9, which is 9. The difference of the y's, 1 minus negative 2 is 3. So therefore we have the distance is equal to the square root of 90, which is 3 to the root of 10. In this, over the course of the year, you have to remember, just like in PST, you have to reduce all radicals. Now let's find the equation. Now here's where I want you to really pay attention. I am not going to find it like you guys found it back in middle school. Now what I'm going to do is I'm going to find the slope of B to C. So 1 minus negative 2 over 0 minus 9. 1 plus 2 is 3 over negative 9, so it's negative 1/3. Now I know I have the y-intercept. So in reality, I know you could just do negative 1/3 x plus 1. But in general, I'm not going to be giving you the y-intercept. So in point slope form, you could pick any point on this curve. It does not matter which point you pick on the line. So I'm going to pick point C, for instance, just because I feel like being different. I simply would plug in negative 2 to here, which would make this plus, and then plug in 9 here, and that would be my equation. Notice there would be the other form as well. There could also be y minus the b point, 1, equals negative 1/3 x minus 0. If you simplify these, they will all match the slope-intercept form. There is no need, unless I tell you to, which is going to be very rarely, to simplify a point-slope form. Number 2, let's find the equation of the altitude from A to BC. Well, if we know the slope of BC is negative 1/3, and the altitude must be perpendicular to it, then that point, I'm going to call that intersection D. So AD, its slope, must be equal to 3. So again, I'm going to set this up in point slope form, y minus 3, x minus, and we know it goes through point A. So point A is 8, 5, so plug in my 8, plug in my 5, and I am done. Question 3. Find the point where the altitude from A intersects segment BC. So here we have a system of equations from the first section. So we have to solve when y minus 5 equals 3 times x minus 8 is equal to y equals negative 1/3 x plus 1. So we can substitute y in for the other one. So negative 1/3 x plus 1 minus 5 equals 3 times x minus 8. So we have 3x minus 24 equals negative 1/3 x minus 4. Let's add the 4 over, we get negative 20. If we minus 3, we get negative 10/3. And then lastly, we can real quickly multiply by 3 to get negative 60 divided by negative 10 to get 6. And if you plug it back in, you get y equals negative 1. From this, I could find the length of the altitude from A to BC. So this is just simply a distance formula problem. The square root of the A's, so again I'm going to write these points back down. You have 8, 5 as point A, and point D is 6, negative 1. So the difference of the x's is 2. The difference of the y's is 6. So therefore the distance is 4 plus 36, which is 40, which is 2 to the root of 10. From there, last question, we can find the area of this triangle. Area equals 1/2 base times height, so 1/2 times 2 to the root of 10, which is the height actually, times the base, which was the square root, 3 to the square root of 10, and that is equal to 3 times 10, which is 30. I wanted to do this problem because this really is a better model of what you should be anticipating next year. So this problem is multidimensional and involves concepts from all different parts of this chapter. And you can expect tests and quizzes to look more like this, where I take problems from different sections and kind of combine them and make you apply all the different things that you've learned so far, especially during this review. So with that, you should be ready to complete the third section of the summer assignment.